Greetings to everyone. So today we are going to discuss about shape factor and the problems related to shape factor. Okay. So first one is, what is shape factor? So what is shape factor? So we are going to denote the letter for shape factor is equal to S, capital S. So it is the ratio between the plastic moment to the elastic moment of the section. Plastic moment to the elastic moment. So elastic moment we are going to denote it by capital letter M. So now we all know that M is equal to, that is M by I is equal to sigma by Y. So the sigma we are going to stay called as yield stress sigma Y. Okay. So from that M is equal to sigma Y into I by Y. So this I by Y is nothing but Z. Okay. So with respect to Z, so if it is plastic, then we are going to say Z is equal to ZP. Okay. If it is at elastic state, we are going to say it is ZE or Z. Okay. So now, as per the statement, we are going to say S is equal to MP by M. So here, if it is elastic state, then sorry, plastic state, then our formula is changed to sigma Y into ZP. Okay. Similarly, here for M is equal to sigma Y into Z. So sigma Y is getting cancelled. So that shape factor is defined as S is equal to ZP by Z. Okay. So either we can say shape factor definition as the ratio between the plastic moment to elastic moment, or else plastic section modulus to the elastic section modulus of the section. Okay. So we can say in two aspects shape factor. Now let us move on to the shape factor for the different cross section. Okay. Finding shape factor value for the different cross section. Okay. So next. So here, as per our previous statement, shape factor is S is equal to ZP by Z, or else MP by M. Whereas ZP, how we are going to denote now? A by 2 into Y1 bar plus Y2 bar, which is nothing but with respect to the section. So that we have discussed in the last class, with respect to the neutral axis, the above portion centroid will be called as Y1 bar. With respect to the neutral axis, the below portion centroid will be called as Y2 bar. So their center of gravity we have to find out. Then the total area divided by 2. So this is the formula we are have to. Okay. So our conventional Z becomes, okay, that is modulus, section modulus becomes, okay, I by Y. Okay. So this I by Y is nothing but Y max. Okay. So I value is depends upon the nature of the cross section. Okay. Either it is a rectangular or square or circle or triangle. Based on that, the value of I will change. Okay. So this is the thing we are going to use. Now, first of all, we should go for shape factor for the rectangular section. Shape factor for rectangular section. Okay. So this is our rectangular cross section. It have the breadth of B and the total depth of small d and have the neutral axis at its center. Okay, so with respect to the neutral axis, the compression fiber will be at a distance of d by 2. Similarly, the tension fiber at a distance of d by 2 is available. Okay, and the center of gravity from the neutral axis, that is y1 bar, and the y2 bar is available from here and there. Okay, below and above the neutral axis. Okay, now let us move on to the shape factor. So we all know that shape factor S is equal to ZP by Z, such that ZP is equal to A by 2 into Y1 bar plus Y2 bar. Okay, so area A is equal to breadth into depth, whereas Y1 bar is equal to Y2 bar, since because of the section similarity. Okay, so here it is locating at a distance of d by 2 divided by 2. Okay, so d by 2 the whole divided by 2, so that the y1 and y2 bar value becomes d by 4. Now let us move on to the z value. So elastic section modulus z, so I by y. Okay, for the entire section. So for the entire section, the I value is BD cube by 12. Similarly, Y value for the entire section, Y max value is for the entire section is D by 2. That is, for the total section, the centroid will be lies at its center. Okay, so Y max equal to D by 2. Therefore, ZP becomes, okay, A by 2. So BD by 2 into d by 4 plus d by 4. So BD by 2 into 4, I am going to take it as common, so that I can get 2 times of d. 2 to get cancelled. So BD squared by 4 is the value of ZP. Okay. Next I need Z value. So Z is equal to I by Y. So BD cube by 12 divided by Y value is d by 2. So d by 2. So BD squared 6. So Z is equal to BD squared by 6. Therefore, shape factor S is equal to ZP by Z. So ZP value is BD squared by 4. BD squared by 4 divided by BD squared by 6 is that value. So get cancelled. So it becomes 6 by 4 such that 1.5. So S is equal to 1.5 for the rectangular section. So this is the unitless quantity. So there is no unit for shape factor value. So next we should go for diamond section. So shape factor for diamond section. So the figure is like this. So the neutral axis is lies in the mid of the section, then neutral axis. The breadth of the section is said to be B, and the total height of the section is said to be small d, and with respect to the neutral axis, the section is divided into two in the top and bottom, at a height of d by 2 d by 2. Okay. Now the centroid of the first section is y1 bar, top of the section. The second section centroid will be lies at a distance of y2 bar from the neutral axis. Okay. So if I'm going to take it as a separate specimen, okay, then it can be divided into two. That is d by 3, sorry, 1/3 of d by 2 and the remaining height 2/3 of d by 2. Okay, so this is how we can have, and the breadth is as usual. Now shape factor S is equal to ZP by Z, whereas ZP is equal to A by 2 into Y1 bar plus Y2 bar. Okay, now whereas A is equal to two triangles we can split up. Okay, now split up like a two triangles. So half into B into H into two triangles such that half BD we can get area. Okay, next we need y1 bar distance and y2 bar distance. Okay, so the both distance are equal. Y1 bar plus, sorry, y1 bar is equal to y2 bar. So here from the neutral axis we are going to calculate here. Okay, so the distance is 1/3 of d by 2. So 1/3 of d by 2. So our distance is d by 6. Therefore, ZP value becomes A by 2, half into B into D area divided by 2 into D by 6 plus D by 6 because of section symmetry. So the total value becomes, so 1 by 4 times of BD into 6, I am going to take it as common, so 2D I can get. So ZP becomes A by 2. So area is half into B into D divided by 2 into D by 6 plus D by 6. Okay. So therefore 1 by 4 times of breadth into depth into 6, if I am going to take it as commonest, then it becomes 2D. Okay, then 3. So the total value of ZP becomes BD squared divided by 4 into 3, 12. Okay, this is the value of ZP. Next we should move on to Z value. So I by Y. So Z is equal to I by Y. Okay, whereas I value, so I value we are going to say BD cube by 12 into two parts we are going to take it as, okay, into 2. So instead of D we are going to substitute D by 2. So instead of D we are going to substitute as D by 2. Okay, so I is equal to B into D by 2 the whole cube divided by 12 into 2. So now it becomes 6. So B into D cube divided by 2 into 2 into 2, 2 into 2, 4, 4 into 2, 8, 8 into 6. So the value is BD cube divided by 48. Therefore, Y value, okay. So for the entire section, we know that the Y value is D by 2, okay. Therefore, I by Y is equal to Z is equal to BD cube divided by 48 the whole divided by BD cube, sorry, D by 2. So instead of D, it is D squared. This is 24. So Z value becomes BD squared divided by 24. Therefore, shape factor S becomes ZP by Z. So ZP value is BD squared divided by 12. BD squared divided by 12. The whole divided by Z value is BD squared divided by 24. So 24 divided by 12 becomes 2. Therefore, S is equal to 2. This shape factor value is equal to 2 for the diamond section. For the diamond section. Okay. So this is related to our diamond section. So from that, if it is a rectangular section, then S value is 1.5. If it is diamond section, then S value is 2. Okay. Next, we should move on to the triangle section. Okay. Next is shape factor for the triangle section. Shape factor for triangle section. Okay. So this is the triangle section. So it have the breadth of B and the overall height of D, small d. Okay, now, and for the triangle section, the neutral axis is lies in the 1/3 of the base distance from the base. Okay, so that this distance is D by 3 and the balance height is 2/3 of B. So now I am going to say from the neutral axis to the above portion, I am going to call it as a D1, and the breadth at the neutral axis, here it going to calculate as B1. Okay. Now the section is divided into two form. Why we are going to say this one into two form means, in order to calculate the value of y1 bar and y2 bar. Okay. So this is on triangular section. The value of y1 bar we have to calculate. So here it is 1/3 of D1. This total height is D1. Okay. So here from the similar triangle rule. Okay. So D1 by D is equal to B1 by B. We can get it from this total triangle. So from here, I can say D1 is equal to B1 into D by B. So equation number 1. Next, we should go for the another thing. Logic, that is, with here the neutral axis will be available or running here. Okay, so with the neutral axis is dividing the entire section into with respect to the cross sectional area, two similar sections. Okay, two similar area, that is called neutral axis. Okay, so if I am correct, then this is section 1 and this is section 2. The A1 is equal to A2 is equal to A by 2. So this is the logic I am having. So A1 is equal to A by 2. That equation I am going to use. So A1 is nothing but this is our first section. So B1 half BH formula we are going to use. So half into B1 into D1 is equal to area 1 is equal to A by 2. So A by 2 is nothing but total area. A half into B into D divided by 2. So this 2 get cancelled. So B1 into D1 is equal to half into BD. Okay. So this is the another equation. So here I already calculated that D1 is equal to B1 into D by B. So that I am going to substitute now. So in this equation, substitute equation 1 into 2. Okay. So B1 into, instead of D1, I have calculated that B1 D divided by B. B1 D divided by B is equal to half into B into D. Okay, so D get cancelled. So B1 squared is equal to half into B squared. This B comes here. Okay, so therefore B1 is equal to root under B squared by 2. So from here B1 is equal to B by root 2. So this is another equation. Okay. Similar way, I can have one equation here. That is D1 equal to B1 D by B. D1 is equal to B1 D by B. B1 D by B. So substitute B1 value here. So D1 is equal to, instead of B1, I am going to substitute as root into B2 into D by B. So B get cancelled. So D1 is equal to D by root 2. Okay. So this is equation number 4. So here B1 is equal to 1 divided by root 2 is the value of 0 0.707. 0 0.707 times of B, and D1 is equal to 0 0.707 times of D. So this is the equation we have derived from the previous link. Now we should go on to ZP. That is shape factor S is equal to ZP by ZA, whereas ZP is equal to total area divided by 2 into Y1 bar plus Y2 bar. Okay. So here Y1, so this is B1, that is 0 0.707 times of B. Similarly, D1, that is 0 0.707 times of D as per the earlier derivation. Okay, now this is Y1 bar. So Y1 bar I already said with respect to this equation, sorry, this shape, 1/3 of D1. Okay, therefore Y1 bar is equal to 1/3 of D1. So D1 is equal to 0 0.707 times of D. So 0 0.707 divided by 3 becomes 0 0.235 times of D Y1. Okay, next to Y2. So Y2 remaining area, it is like this. Okay, so this portion is nothing but D minus D1. Since the total height I have taken as D, and from the neutral axis, the above portion we have denoted as D1. So the balance portion is D minus D1. Okay. And this is B1. So B1 is equal to 0 0.707 times of B, and this is B, total depth. Okay. So with respect to neutral axis, what is the height? That is the Y2 bar. Okay. So the formula for Y2 is equal to A plus 2B divided by A plus B into H by 3. So here, what is A? A is equal to B1. B is equal to as usual B. H is equal to D minus H is equal to D minus D1. Okay. So here D minus D1 is equal to 0.707 D. So 1 minus 0.707 becomes 0.293. 0.293 times of D is the value of H. Okay. Now substitute these values into this equation. So instead of A, I'm going to substitute B1. So instead of B1, I'm going to substitute 0.707 times of B plus 2 times of B divided by A, 0.707 times of P plus B, and into H by 3. So H is equal to 0.293 times of D divided by 3. Okay. So here 0.707 plus 2, the whole divided by 1, that is 1 plus 0.707. So the answer is 1 point. So at top it is, so BB get cancelled. Okay. So the value is 1.585. So B is going to take it as common. So BB get cancelled. Okay. Multiplied with 0.293 divided by 3. It becomes 0.977 D. Okay. Therefore, Y2 value is 1.585 multiplied with 0.977. So the answer is 0.155 D is the value of Y2 bar. So substitute this equation into ZP. So whereas A value half into breadth into depth. Okay. Therefore ZP becomes half into B into D divided by 2 into Y1 bar. So Y1 bar value is 0.235 D. 0.235 times of D plus Y2 bar value is 0.155 times of D. 0.155 into D. So here 1 by 4 into BD. So 1 by 4 into BD into 0.235 plus 0.155. D is going to take it as a common term. So it becomes 0.39 times of D. So 0.39 divided by 4 becomes 0.0975 times of BD squared is the value of ZP. Next, Z is equal to I by Y max. Okay, for the entire section. So here it is I value is equal to BD cube by 36 for the rectangular section, and Y max value is 2/3 of D is the Y max value. From the triangle neutral axis. Okay, 2/3 of the D is the maximum value. So if I am going to substitute this, then Z value becomes Z is equal to I by Y. So BD cube divided by 36, the whole divided by 2 by 3 times of D. So D squared. So 3 gets 12. So Z becomes BD squared divided by 24. Okay. Therefore shape factor S is equal to ZP by Z, whereas ZP 0.0975 BD squared, whereas Z is equal to BD squared by 24, BD squared divided by 24. So d square get cancelled. So 24 into 0.0975 becomes 2.34. So 2.34 is the shape factor value for the triangular section. Thank you.